today I'm going to be talking to you about how to multiply two matrices together. So we've already talked about addition and subtraction. Today we're going to be moving on to multiplication. And there's several rules involved with multiplying matrices, so bear with me as we go through them. So the first one is that to multiply two matrices, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So the columns of the first matrix has to be the same as the number of rows in the second matrix. The second rule we have talks about the size of the new matrix. So after we multiply our two matrices together and we get our answer, we want to know what the size of that matrix is going to be. So the size of the new matrix is going to have the same number of rows as the first matrix and the same number of columns as the second matrix. And I know those two rules sound kind of similar. We've used rows and we used columns from different matrices. So let's look at an example together to see how that applies. So if we had a 2x3 matrix and a 3x3 matrix, to figure out if we can multiply them together, we're looking at the columns in the first matrix and the rows in the second matrix. And when we look at the columns of the first matrix, that's this number right here. The second number is the columns. So our first matrix has 3 columns. Next, we look at the rows in the second matrix, and the rows are the first number for this second matrix. So it has 3 rows. So we've got 3 columns in the first matrix and 3 rows in the second matrix. So since those numbers are equal, the columns of the first matrix are equal to the rows in the second matrix, we can multiply them together. So because the columns of the first matrix and the rows of the second matrix are the same, we can multiply them together. So those numbers in the middle, when you write the sizes side by side, if those are the same number, then we can multiply them together. So since these two numbers on the inside were both 3s, we can multiply them. Then the numbers on the outside of the sizes, on the outside edges, tell us the size of the new matrix. So we take if you look up here, the rows from the first matrix, which was 2, and the columns from the second matrix, which was this 3, that tells you the size of the new matrix. So the new matrix would be a 2x3 matrix. It would have 2 rows and 3 columns. Let's look at another example. So if we had a 2x4 matrix and another 2x4 matrix, to figure out if we can multiply them or not, we need to look at the columns of the first matrix and the rows in the second matrix. So remember, we said those are the two numbers closest to the inside when you write the sizes side by side. So we've got a 4 for the number of columns in the first matrix and a 2 for the number of rows in the second matrix. And since 4 and 2 are not equal, we cannot multiply them together. The number of columns in the first matrix does not equal the number of rows in the second matrix. So we would not be able to multiply those together. And then you see the black line there, that's a mistake I made. So we're just gonna scroll past that and look at a couple of examples. All right, so for our examples, we've got 3 different matrices that we're gonna try and multiply together. And we're actually, for this time, we're just going to use a calculator to multiply these. And in a future video, I'll show you how to multiply them by hand. But the main way you're going to do these is using a calculator. Multiplying them by hand can get kind of complicated. So we're going to use a calculator to multiply these. But before we do that, we need to know the size of our matrices so that we can type them into the calculator correctly. So first, we need to find the number of rows for the first matrix and the number of columns. So our first matrix has 1, 2 rows, and then 1, 2, 3 columns. So this first matrix is a 2x3. Next, we're going to look at the size of the second matrix. So the second matrix has 1, 2, 3 rows, and then 1, 2, 3 columns. So the second matrix would be a 3x3 matrix. So these are the sizes we're going to type into our calculator. So let me see if I can get this to work in a split screen. There we go. I'm trying to get it to work so I can see both at the same time. but y'all know how technology works with me. All right, here we go. We're getting somewhere, maybe. I should have done this before I started filming, but y'all just get to sit here for a couple of minutes and watch me do this. All right, there we go. So I'm at symbolab.com, the same calculator I've been using, and it's got that toolbar that you can use, which is really handy when we work with matrices. And then we enter our problem down here in the text line. So we want to enter this problem, so we need to insert a 2x3 matrix. So if you come up to this toolbar, if you go over to this side, there's something that looks like these parentheses with the boxes around it. That's how we insert a matrix, and then we just need to select a 2x3 matrix. So if we come over, we see right here that there's a 2x3 matrix, and that's going to allow us to insert this matrix here. So we start with 1, 3, 2, -4, 5, -6, and then we want to multiply that. So we need to insert a multiplication symbol, and I just use the one that's on my keyboard. And then our second matrix was 3x3, so we insert a 3x3 matrix. And so we have 2, 5, -1, 0, -3, 1, 0, 2, 2. All right, so that's our second matrix. And we're going to come over here and click Go to simplify our problem. And in just a second, it's going to pop up here with our answer. Remember, you have to scroll down to where it says solution. And this right here would be our solution. So if we go ahead and write that out, our final answer is the matrix 2, 0, 6, -8, -47, 3. So let's see if I can get that written out on here. Y'all just get to watch me struggle with technology for a second. Okay. And I lost my calculator. Every time, you guys, every time I use technology, you get to watch this happen. Okay. 2, 0, 6, -8, -47, -3. All right. So that would be our first matrix like you see right here. So let's go ahead and look at another example. So you can come back up here. And I'm struggling with this calculator a little bit, y'all. There it is. Okay, and where we had the problem earlier, let me erase this for a second. All right, where we had the problem earlier, we can actually just get rid of that and type in our next problem in the same place. So our next problem, we have the matrix -6, 1 times 2, 1, 9. So when we look at the sizes of these two matrices, we need to figure out if we can multiply them together. So our first matrix has 1, 2 rows, and then just the one column. So that's a 2x1 matrix. Our second matrix has just this one row, but then 1, 2, 3 columns. So that's a 1x3 matrix. And so then when we open up our calculator to type it in, we need a 2x1 matrix. Oh, goodness. A 2x1 matrix and a 1x3 matrix. So if we come on over to our calculator, if I can manage to get this to work. So we're once again going to insert a matrix, so we can come over here to this tab. Possibly. There it goes. And this is the one where you can just select the matrix size. You actually have to move it around. Or if you would prefer, you can click this little arrow. Not that one. You can click this up here that says full pad, and that'll take you back to that normal matrix pad where you can select this button here. So we need a 2x1 matrix, so we can look and see if that's one of the options, and they do have that here. So our 2x1 matrix was -6, 1. And then we're going to multiply that by our second matrix, which was a 1x3. So we need to insert a 1x3 matrix. And our 1x3 matrix was 2, 1, 9. And then if we come on over, we can click Go. and then scroll on down and get our final answer, which is right here. So notice our final matrix looks a lot bigger than either of the matrices we started off with. So sometimes matrix multiplication can work like that. So our final matrix is -12, -6, -54, 2, 1, 9. So once again, let's see if I can somehow manage to write this all out. So we get the matrix -12, -6, -54, 2, 1, 9. All right. So that would be our second matrix. And I just accidentally deleted it all. Let's see. There we go. Bring it back. All right. So that would be the answer to our second problem. And so now we're going to look at this last one down here. So we have the matrix 2, 2, 3, 3, 4, 4 times -1, -1, -2, -2, -3, -3. And just like the last problems, first we're going to figure out the size of each matrix. Then we're going to try and type it into the calculator and see what happens. So our first matrix has 1, 2, 3 rows, and then 1, 2 columns. So this would be a 3 by 2 matrix. And the second matrix has 1, 2, 3 rows, and then 1, 2 columns. So we've got two different 3 by 2 matrices. So if we come over to our calculator and come back up to where we inserted the problem, we can clear that out. I'm going to click on full pad again, come over to where there's the button for inserting a matrix, and then we need a 3 by 2 matrix, which is right here. And then we just type in the numbers. So 2, 2, 3, 3, 4, 4 times. Our second matrix is also 3 by 2, so we'll click that. And it's -1, -1, -2, -2, -3, -3. And then once we've got both matrices typed out, we can come over and click go. And when it loads and gives us our solution, it's going to give us this error message that they're incorrect dimensions. So if you remember our rules for matrices, we said the number of columns in the first matrix had to be equal to the number of rows in the second matrix. So our rule is that this number and this number have to be the same. Those numbers closest to the inside when we write out the dimensions or when we write out the sizes. Well, 2 does not equal 3. So since these are not the same number, we cannot multiply the matrices together. So because of that, this problem would have no solution. Okay, so that one would have no solution. So all of these did follow that rule. If you looked up here, and I erased the sizes, but this was a 2 by 3 matrix. This was a 3 by 3 matrix. So we had a 2 by 3 and a 3 by 3. So 2 by 3 and a 3 by 3. And these two numbers in the middle, the columns of the first matrix and the rows of the second matrix were the same number. So we were able to get an answer. Same thing down here. We had a 2 by 1 matrix, and this one was a 1 by 3 matrix. So since these two numbers in the middle were the same, the columns of the first matrix and the rows of the second were the same, we were able to get an answer when we typed it into our calculator. And then our other part of our rule said if we could multiply them to find the size would be the rows of the first matrix and the columns of the second matrix. So our final answer should be 2 by 3. Well, up here we had 1, 2 rows and 1, 2, 3 columns. It's kind of hard to see from the way I wrote it out, but it's a 2 by 3 matrix, so it follows that rule. If we come down and look at our next one, we were able to multiply these because the number in the middle was the same. So the numbers on the outside tell us the size of our matrix. So here we have a 2 and a 3. So our final answer should be 2 by 3. And if we look over here, we had 1, 2 rows and 1, 2, 3 columns. So it was a 2 by 3 matrix. So that's how we multiply two matrices together. Hopefully this makes sense to you guys. Use your calculators to help you out. And then if you've got any questions, let me know. All right, you guys, so make it a great day or not. The choice is yours.